Hello, we are Team 2, and I'm going to be talking about our concept design. In this presentation, I'm going to talk about the theme of our project, the concept, the need statements and target specifications, our device model, how it's going to work, the crank gear assembly, the natural science and applied science, how we will build it, the materials we will use, what it will teach, and then I'm going to summarize everything at the end. We are making our device for the Franklin Institute, which is located in Philadelphia, Pennsylvania. The Franklin Institute has many carts of different themes called interactives, which teach something about science. The theme of our device will utilize the hidden power theme, which will include information about where electricity comes from and what the methods of generating energy from both renewable and non-renewable sources. The concept of this device is to show how physical energy made by a person can create electricity. By physically turning a handle attached to a generator, electricity will be created and transferred to a series of small light bulbs, which will light up according to the amount of energy that is created. By using bike gears, we will create multiple user inputs to show how different amounts of electricity are generated according to the amount of revolutions the generator will have. Our need statements were generated from interviews with our stakeholders. The two stakeholders we interviewed are Shauna from the Franklin Institute and Dr. Lyant from the Materials Department of Drexel University. Both of our stakeholders participate in running events for students to learn about science. So the first need statement is that the device can be assembled quickly. This is important because some of these presentations will have to be set up very quickly and easily in order to run them smoothly. So our target specification for this need is that the device is assembled in less than 5 minutes. The next need statement is that it must fit to be stored inside the cart. This is important because this object might need to be transported around the Franklin Institute, so it needs to fit inside the cart that it can be transported by. The stowed device has to be within the volume of 2 cubic feet in order to fit in this cart. The next need statement is that the device is not heavy. This is also important for transportation and for setting up for the presenter. We are trying to make the device less than 6 pounds. The next need statement is that the device is not distracting from the presenter speaking. This means that the device has to be pretty quiet in order for students to hear what the presenter is talking about. Our target specification for this is that the production noise is 70 decibels. The last need statement is that the device is visually engaging, which means this device should have colors and lights to draw the user's attention in order to be noticed from a distance. Here's a visual representation of our device. Students will crank the handle, and as it spins, the LEDs on the top will light up. As the handle spins faster and longer, more lights will start to light up. The gear system and generator are located inside the box, and in the real-life model, the box will have clear plexiglass in order to show the user what is going on inside. Another possible addition to this model is to include a voltmeter, which will show how much power is being generated. As the mechanical energy of turning the hand crank is being applied, the electrons that are being pushed by the magnets will travel through the copper wire and into the LED lights. The generator will be made by putting a coil of copper wire in the middle and surrounding it with strong neodymium magnets. By spinning the magnet around the coil, the energy will travel to the lights. Implementing different sized gears will provide the user with multiple inputs. The user will see that when they spin the smaller gear, there will be less light coming from the lights, and when the larger gear is used, there will be more light created. The concept is that the lights will be connected in a series with resistors, and the amount of lights that will emit light will correspond to the amount of energy that is created. The way we are going to make our gear system is by using bicycle gear technology. We will have a lever that can be adjusted to the desired gear. All levels will be labeled on the side for the user to clearly see which gear is being used. The purpose of our device is to demonstrate a natural and applied science. In this case, the natural topic will cover the topic of electricity. This will be explained through the mechanically generated kinetic energy. The applied science topic is the concept of using mechanically generated electricity to power lights. We will use physics and engineering to convey this concept. The desktop-sized device will consist of a main enclosed part where the generator is located, and in addition where LEDs will be lined up and connected to the generator. The supplies we expect to use are a wooden enclosure and base, a plexiglass safety shield, which will be clear so you can see inside, a homemade generator, which is going to be made of magnets and copper wire, wires and crimp connections, resistors, and LEDs. What our device will teach is the generation of electric power by mechanical energy with the use of magnets and spinning wires. This will show the distribution of power to the end user. By allowing the user to change gears to different sizes, they will see how the diameter of the gear affects the amount of times the generator will spin, which in turn will generate different amounts of electricity. To summarize our presentation, I talked about how our device will be used to educate the end user in power generation and how the device demonstrates natural and applied sciences. We hope that students will find our device helpful in understanding these concepts, but most importantly, we hope that they have fun learning about it. Thank you for your attention.